right, today this is your inequalities video notes. Make sure your notes are in front of you. Make sure you're filling in all the things that you don't see on your paper. If you look at this one, the top right-hand corner in the red here, these are what we're used to. Equations have equal signs, right? 2 plus 3 we know is 5, or x plus y equals z. These are equations because they have an equal sign. Some of you say they have an answer. I'll take that. But we're not talking about equations today. We're talking about something called inequalities. So let's look at that word for a second. Inequalities. So the prefix in, means not. So if you are incorrect, that means you're not correct. Okay, in means not. And then you can easily pick this word out of here, equal. What we're talking about is these things are not equal. So if you look at the equation, we're saying the left side and the right side are equal. They balance. We talked about balancing the equation. Inequalities are not equal. Okay, they're not. So let's talk about those. You've seen these guys before. You could have less than, equal to, or greater than. We're going to be dealing with those types of things when we talk about inequalities. So if you need to write those down to know the difference, this is a good time to do so. And let's take a look here. This says, this inequality, notice it has a less than. If it has a less than or greater than, it makes it an inequality. This inequality says 5 less than n. 5 less than n. So what I'm asking you is, what are some possibilities for the number n? So could I say 6? So if I went over here and I said 5 is less than 6, is that true? Yes, it is. Okay. Could I put 100 then? Yes, I could. Could I put 5.102? Is that greater than 5? Yes. Yes, it is. Could I put 5 itself? No, I could not. That would say that 5 is less than 5. That is not true. Okay, could I put 4? I could not put 4. 4 is not less than 5. Or, sorry, 4 is less than 5. So that does not work. So this says to list 5, we only listed 3. So I'm going to put 12, and I'm going to put 1,000. So what I would like you to do is, first of all, let's say this one correctly so you know what we have here. It says z is greater than 3.4. So if you would please hit pause and put some possibilities for z. So z is greater than 3.4. So could I put 3.5? Yes, I could. Could I put 4? Yes, I could. Could I put 10? How about, I don't know, 3,000? And, I don't know, 21.2. So if you put anything that fits into that, great. Could you put 3.4? No. Could you put anything less than that, like 3.3 or 3 or 0? No, 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 no. So that's a quick intro to inequalities. The next level looks like this. So this is a symbol that means greater than or equal to. So make sure you're filling these in. Make sure you hit pause when you need to. And this symbol means less than or equal to. So what's different from those and from just the regular equal, less than or greater than? You see the little line underneath, right? So you see this little line under here. Think of that as the bottom part of the equal sign. So you're combining a less than with an equal sign, and you're combining a greater than with an equal sign. So let's look at what the story is here. It says determine whether y being 12 makes the inequality true. So if we put 12 in here for this y, so 12 greater than or equal to 30. Is 12 greater than 30? Definitely not. Is 12 equal to 30? Definitely not. This is no. And we could say something like 12 is less than 30. Okay? Let's try another one. Let's try number 2. It's a little more complicated. So what are we doing? We know what y is. We're substituting y, 12 for y. So if we put 5 in here times 12 minus 6, like so. Well, 5 times 12 we know is 60. And 60 minus 6 we know is 54. Is 54 less than or equal to 55, yes it is. 54 is in fact less than 55. So what do we have to do? We had to substitute and solve. This first one, we put the 12 in for the y. There was no solving because it was just a 12. And the second one, we had to substitute what you see in the green there. So if you would, please hit pause and try number 3. So I'm going to substitute 12 in for y. So what I have is 12 over 2 less than or equal to 4. We know that a fraction means to divide. 12 divided 2 is 6. Is 6 less than or equal to 4? No, it is not. 6 is actually greater than 4, so we'll say 6 is greater than 4. So in any of those, could the answers have been equal? Yes, they could have. So for number 1, could I have had 30? Is greater than or equal to 30? Yes, definitely. For number 2, could we have had that 55 less than or equal to 55? Yes, we could have. And for number 3, same deal. Could we have said 4 is less than or equal to 4? Yes, we could. So notice that an inequality can be greater than or less than. They can also be equal to if you have this symbol with a little equal underneath. So if you would, let's do number 4 together. It says the temperature every day for a week was below 32 degrees. So we don't know what the temperature was, but we know every day for a week it was below 32. So let's just put a T for temperature. And how are we going to write below 32? We are going to write less than. Could the temperature have been 32 that week? It could not. It said the temperature was below. So we just keep the less than sign. If it says the temperature was 32 or below, then we would have had 32 or below would look like this. That counts 32, but we're not counting that. So if you would please hit pause and try number 5. So this says Mr. Wiedrick has 10 or more cupcakes. So we'll put C for cupcakes. So I could have 10. Could I have more than 10 is the question. The answer is yes, I could have more than 10. So we're saying greater than or equal to. Now think about that. Put a number in for the C. So I could put a 10 there. 10 equals 10, we know that. But 10 or more cupcakes. So for the C, could I put a 15 in here? Is 15 greater than or equal to 10? Yes, it is. So notice the difference between those two. The first one, number 4 here, said the temperature is below 32, so T is less than 32. This one says I have 10 or more, so I have to have something that is greater than or equal to. Greater than or equal to. All right, so now we're going to graph these guys. So you're onto the back of your paper. Or, sorry, you're on the bottom of your paper. So this says x is greater than negative 6. So what I'm going to do is, you have yours graphed already. I'm going to put an open circle on 6. And I'm saying x is everything that is greater than 6. So if you went to the left here, these numbers become less, right? They're becoming smaller. And if I go to the right, these numbers are becoming greater. The closer you get to 0 when you're negatives, the closer you get to 0, the greater the numbers are. Or think of if this were temperatures, the warmer they are when you're going to the right. So I want to draw a line that shows everything that's greater than negative 6. So my line's going to go to the right because going this way is greater than negative 6. If it helps you, here's your symbol, just like the one we're using here. I sometimes will do this to remind me that it's drawing the arrow to the right, just like the red one here. If that helps you, great. So if you would please pause and graph that one. So this says y is less than 12. So think of these numbers up here. Which ones are less than 12? The ones going to the left. So I'm going to draw my arrow to the left like so. Okay. If we look at the next one down with the x is greater than or equal to 20, So we put our symbol here, and look what's different. We would call this up here an open circle, and we would call this a closed circle. Here's the difference. A closed circle means we're counting 20. An open circle means we're not counting -6, we're counting everything above it. Here we're counting 20, right? It's equal to, so we want to count this 20, it could be 20. And then we're going to count everything that x is greater than. So everything greater than 20 is to the right, these are all greater, so my arrow goes that way. So review that one in your head real quick. Closed circle, when you have an equal sign, that's closed, meaning that we're counting the 20. Up here, open circle is when you don't have the equal sign. No equal sign, open circle. We're not counting the 12, we're not counting the -6, we are counting the 20. All right, so hit pause and try that last one, please. So closed circle on the -4, like so. This says k is less than or equal to -4. So which ones on here are less than -4 or colder than -4? I'm going to the left. Like so. Again, if any of the graphing kind of threw you at all, please go back, rewind, listen to it again. All right, last piece here. Here's our symbols bouncing in again. Greater than or equal to, less than or equal to. And the problem is saying, give an example when the inequalities will be true and when they will be false. So let's get our questions up here. This says 53 is less than or equal to 9h. Okay, so I want an example when these will be true. So basically what I'm saying is 53 has to be smaller than what I have here. Well, I could do things like 9 times 5. I like to start with 5. 5s are easy, right? 9 times 5 is 45. Would that work? 53 is less than or equal to 45. 53 is not less than 45, right? So we could use that for one that would be false. All right, let's try 9 times 6. 9 times 6 is 54. Is 53 less than or equal to 54? Sure is. So h could be 6 to make it true. Could be, I shouldn't put a 5 here, should I? H could be 5 to make it false. So the 5 and the 6 came from here. So if you would please, last piece of the puzzle here is to try number 2. So give me an example where y could be true and where y could be false. Hit pause, go ahead. So it says 23 minus y is greater than or equal to 12. So again, I'm just going to use 5. 5's easy. Oops, not 25. I'm going to use 5. Let's start this over here. 23 minus 5. Is that greater than or equal to 12? 23 minus 5 is 18. Is 18 greater than or equal to 12? Sure is. So to make this true, we could say 5. And then to make it false, let's try something. Now, I'm going to give you some correct answers here so that you see it right, but could you come up with a few and try and see which ones are right and wrong? Of course you could. Let's use 10. We're using easy numbers here. 23 minus 10 is 13. Is 13 greater than or equal to 12? It is, right? So that would be another one that would be true. 10 would be. But I've gotten a lot closer. So instead of 10, let's use 20. 23 minus 20 is 3. Is 3 greater than or equal to 12? No, it definitely isn't. So we use an example for 3. Feel free to go back, rewind, stop when you have to. Try the back of this assignment for homework.